We're going to take a look at Chapter 3, which is Measures of Variability. So what does measures of variability mean? It's kind of a really broad phrase. What we start with is looking at measures of something we call central tendency, which is the middle of something, versus measures of variability, which would be maybe the range things are between. So we have this idea of the middle and this idea of what is the range of my data. So the measure of central tendency gives us a lot of really important information because knowing where the middle is good. So if I'm looking at the sales of homes in my neighborhood and I'm trying to price my house, probably it's important to know what's the middle of the range of houses that are selling. So that information is really useful, but it can also be kind of limited because if I just tell you houses are selling for $115,000, but the house three doors down from you was an outlier and sold for $150,000, then I'm omitting information for you to make your decision. So they really give us an inadequate amount of information about the real range of values in any data set, or what we call the variability of the data set. So it's really important to, in addition to telling us where the middle is, we also need to know what is the range, what are the values between, what is the variance, which starts to measure how far are numbers from the middle, and the standard deviation, which looks at, again, how far is something from the middle. So really, to get a complete picture, we need all three of those. So the range is probably the most common calculation that you're familiar with. To find the range, I just take the largest value and I subtract the smallest value, and that tells me the range of data. So that gives me how wide the range is. In addition to how wide it is, it's usually helpful to state that the numbers fell between 0 and 50, and the range is 50 makes sense because 50 minus 0 is 50. But what if I tell you the numbers fall between 100 and 200 and the range is 100? So there's a difference in understanding there once you start giving the actual lowest and highest value. The range is helpful because the larger the range is, the more spread out our data is. So it gives researchers and the audience of statistics an idea of how big the spread is. And the bigger the spread, the less reliable the measure of the middle is. And it really just helps us kind of get a picture in our head of how that data is actually distributed. The interquartile range sometimes is really neglected in statistics. A lot of people think it's only important when you're looking at a box and whisker plot, but that's really not true. The difference in the 75th and the 25th percentile is what we call the interquartile range. So think about, basically, I have 25th percentile, 50th, and 75. So I'm looking at a range of the data that includes the middle. So it's kind of like including the two middle quartiles, and it tells me how tight are those values based on those quartiles. And it's also important to know if there's a large spread, then you're going to start to see really large numbers in the interquartile range, and it's going to make me start asking some follow-up questions that aren't just about those pieces of information. When I'm talking about variance, this is a little bit of a tricky calculation. So in variance, I take the sum of the squared deviations divided by the number of things, which is really complicated, right? So when I have the variance, I'm going to take my data point minus the mean, and then I'm going to square that out. And I'm going to calculate the variance by adding that up and then dividing by the number of cases. This seems like a lot of arithmetic, right? And that's because we're getting an average. So we're getting to an average because we're adding things up and dividing by the number of things. But it gives us a measurement of dispersion. So think about if you're slinging paint on the wall. The dispersion of the splatter tells us a lot of things about where you were in the room, the angle you were using, and what you were throwing the paint with. Same analogy works in statistics, because before I'm going to release a new drug on the market, I really have to understand all the pieces of it, including that splatter idea. We rarely look just at variance because by itself, it doesn't tell us a lot. We really have to know what is the middle, what is the range, then I need to know what is the variance and what is the standard deviation. And when I have all of those pieces of information, I can start making some good conclusions. So the standard deviation is similar to the variance in calculation, but it's really just the average distance between an individual score and the mean. So when I say a deviation, if I say in this picture the mean is 10 and I have a value of 12, the deviation it's 2 away, right? So that's kind of what we're measuring here, is how far is it from the mean? And we're going to quantify these deviations by certain amounts of information. So we're going to say that 2 points is a deviation, 3 points is 1 deviation. We're going to create a scale, kind of like a map where it's like 1 inch is, 3 miles. That's kind of what we're mapping here. We're creating a map to read this curve. In a standard, when we break down the word, it basically tells us average, and then the deviation is going to be the difference between the score. So we're trying to get an idea of what is the average difference between the scores. This is really useful even by itself because it does provide more information than the variance. But when I have the mean and the standard deviation, I can start to really understand what does my data look like, even without seeing the entire data set. So to recap, the range gives us an idea of the spread. It's useful, but I still need more information, which is why I need things like the standard deviation, which tells me the average amount of spread within a data set. Places we look at range is if whether we want to know all of the response categories on a survey question have been used. So if I want to know the range truly is 1 to 5 in a scale, or maybe it's really only actually 2 to 4 because nobody selected 1 or 5. And this gives us a sense of the overall distribution. The standard deviation is really useful. Researchers tend to provide that standard deviation for us, and that does give us information, especially when paired with the mean. So the range has to have other information. The standard deviation, it's good to have other information. So we talked a little bit last week about statistics and parameters, where statistics are for the sample and parameters are for the population. So for the most part, researchers are really concerned with what the sample is telling us about the population. So this is what is the statistic and how does the statistic relate to the parameter. We want to really make assumptions about the population based on the sample. This is why the formula for calculating the variance and standard deviation are really designed for samples, because they give us good estimates of a population. So you will see different symbols for the mean and the standard deviation with if it's a sample or population. And the key there is just letting us know if we actually have a subset or if we're working with the actual population. So to make sense of this formula for variance, it seems pretty complicated. We're interested in the difference of the deviation from the score to the mean. So we have to calculate this idea of a deviation score, which means here, this is the formula. So I have to take my score and subtract the mean and then square it. So in the previous example, the score was 12 and the mean was 10. So this would be 12 minus 10 is 2. 2 squared is 4. Then I'm going to add the next score. So if the next score is 14, 14 minus 10 is 4. 4 squared is 16. So I'm going to keep adding that up, and then I'm going to divide based on the number of things. If I'm dealing with a population, I divide by n. If I'm dealing with a sample, I divide by n minus 1. So the top isn't changing anything other than notation, but the bottom is changing. To get to the standard deviation, what this formula doesn't show you is if you calculate the variance, all you have to do to find the standard deviation is take the square root of it. So there's no extra work needed there to go from one to the other. It's a simple calculation of being able to take the square root. So the difference in the variance and standard deviation formulas with n minus 1 versus n, basically what happens is if we don't know the population mean, we can use the sample mean as a way of estimating it. We're not 100% sure if it's going to totally match up, but that's kind of the assumption that we're working under. So this accounts for, we know that it's an estimate, and we know that it's not the exact value. So we know that we're not using the actual mean to calculate this. So we're kind of wanting to inflate that a little bit with the variance, and that's why we're dividing by n versus dividing by n minus 1. So n minus 1 creates a slight underestimate, and n should create a slight overestimate. As a reminder, we have some differences in sample statistics versus population parameters. Researchers, if we don't know if it's a sample or a population, our default is that it's a sample. That's just where we kind of assume things are. These are generally considered to be good estimates for the population. So generally, I'm going to get a number. I'm going to assume it's a sample, but I'm also going to assume that it's fairly accurate for the population. If a sample is large, I'm going to assume that it's really close to the population. And if the sample is small, I'm going to assume that it might be a little bit more difficult to tell how accurate it is. So the question is, why do we have variance, and why don't we just go straight to that standard deviation, since if I know standard deviation, it does give me more information? And the reason being is that, well, A, we have to find the variance to find the standard deviation, so one can't happen without the other. And then the variance also helps us understand how far things are from the mean. Once we take the square root of that thing, it kind of brings us into like a modification of the data, which doesn't always help us when we're doing higher level statistics. So here's a few examples of how this works. Let's say this is a chart of students' responses to the question or the statement. I would feel really good if I was the only one who could answer the teacher's question in class. So we can see our sample size is 491 people. Our mean, and notice they gave us scores of 1 to 5. The mean score is 2.92. The standard deviation, the variance, and the range are included on the right-hand side above the graph. When I see a range of 4, that alone doesn't tell me much, except for the data is not very spread out, and I don't know why. The mean of 2.92 isn't extremely informative because I don't really know if people circled 3 in the scale or if a bunch of people circled 5 and a bunch of people circled 1, and it kind of averaged out. So in this case, just having those facts isn't enough. So if I want to start to look at drawing conclusions, I want to start thinking about, well, what was the sample size, okay? Based on that sample size, is it reasonable that most people circled a 2 or a 3? Well, the nice thing is I have that visual, right? And in the visual, I'm getting a pretty good idea of what people circled. If half the circled students if half of them circled 1 and the other half circled 5, I would expect to see a lot of standard deviation there because the scores would be pretty far from the middle, which would be that 3. If they're fairly spread out across the 5 responses, I would expect something that's a moderate standard deviation. So it really depends on how the students circled the individual data points to really be able to make a lot of good assumptions. And the distribution here looks somewhat symmetrical because that mean is very close to the middle. From the standard deviation of 1.43, we also know that they're pretty spread out. They're not clustered super tight together. So in summary, measures of variability give us some information about how spread out things are. The range, the variance, and the standard deviation are 3 most common things we're going to talk about. And when I add all these pieces together, they're going to give us the larger picture of what's happening with that distribution.